Hello, I'm Shane Brinkman-Davis-Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today's topic is one of my very favorites. It is the engineering principle DRY, or don't repeat yourself. So we're going to talk about why you should care about this, and then we're going to talk about some different levels of repetition, some of the problems with repetition, and a little bit about theory around DRY, and then of course a little recap. So first, why do we care? Well, really, as you shouldn't be surprised given the previous episodes, it's all about refactorability. It's about how easily can we change our code in response to new requirements and new bugs or issues that we need to resolve in the code. How do we make our code easier to edit? But there's also another thing. Drying up our code gives us leverage. It gives us leverage to be able to write code faster. And we're going to explore that more here in a moment. So let's start with some examples here. So when we talk about don't repeat yourself, I think most people who've done even just a little bit of software have tried doing the copy paste as a shortcut to solve a problem. You've got a little solution, you copy and paste it somewhere else when you need it again. And I think that many people have learned that that's probably not the best idea. So I'm not going to go into that because that's sort of the most basic version of DRY is don't repeat yourself. Don't literally copy and paste code. And we'll talk a little bit about why that's a problem in just a moment. More so though, let's look at this example of token repetition. So I see this one pretty often where some computation gets assigned to a variable which essentially never gets used. That variable just gets assigned once and read once. And so you can see, if you look at this in the red, it says var user equals get user, and then it says return user. And just look at how many times the string user appears in this source code. It occurs 3 different times. Well, drying this up, we can simplify this whole thing to just return get user. It is absolutely just as clear, and it is much less tokens. And so we've definitely reduced our code size, and we've addressed a few other issues as well, which we'll get into in a moment. So now we're going to keep leveling this up. We're going to go to pattern repetition. So in this example, we've got a file that's seeding our database, and we've got these lines where there's a comment roles, and then there's this class seeds, and then we're calling the seed role method on that class. And then we've got another comment permissions, and then seeds.seed permissions. Users, seeds.seed users, questions, seeds.seed questions. And that code looks reasonably clean, perhaps, but I want to ask you right now, how many times does the string seed appear in this code? It's like 8 times, and there are at least 4 other duplications of strings in that code. So one quick pass, simpler version of this would be just having each of the seeds return the class back as a result. And then you can do seed.roles, seed.permissions, seed.users, and seed.questions. And you can seed all 4 of those things without any duplicate strings at all. It's a much smaller chunk of code to maintain, and it requires a lot less repetition. So at the very least, it's less to read and it's less to write. However, people with some good OO experience will also see that this kind of breaks the encapsulation of this module, and that we as the user of this just want to seed the database. And having to know each of the different tables that need seeding really breaks encapsulation of this module. So really this should be simplified all the way down to seed.all. And if you think about it for a second, this is actually another application of DRY, but this one's a little trickier. We had a repetition of a call pattern. We made the same call for every table in the database. And that's the key thing, quote, every table in the database. Instead of manually writing each table out with the .call for the seeds, we really should just do seed.all. And the implementation of that function really shouldn't list roles, permissions, users, questions. It should just iterate over the list of all the known tables. And then when we add a new table, seeds just works. We don't have to edit this code at all. Last, I want to step one step even higher, which is architectural repetition. And I'm just going to give this one example as a quick walkthrough. And this is a problem that I see in 99% of modern web plus client apps. And it's just an example. There's many ways that architectural repetition happens, but think about this. So you have a client-side app that has a API and a backend that's attached to a database. And every time you add a new DB table in the backend, you basically need to make a server-side model for that table. And then you need to establish a server-side route in the API. And then you need to make a client-side route to connect to the server-side route. And then you need to make a client-side model. And then you make a client-side view to view that table. Which is to say, every time you add each database table, you have a whole slew of work in front of you just to use that throughout your whole system. And it's almost exactly the same pattern every time. Each table has a different set of fields, but that's it. Maybe it has a couple different queries that you might use in each table that you want to custom set up. But the structure of this table to model to route to route to model to view is the same every time. And I see a huge amount of code duplication in code bases that implement a server-side API and a client-side app. So this is just an example of an architectural repetition where you're repeating the same redundant pattern over and over. So now let's take a look about why all this repetition is no good. I mean, obviously it creates extra code and extra work. And so I really summarize it into these three types of problems: inconsistencies, bugs, and code bloat. And we're just kind of touching on code bloat, but think about it for a little bit. It is not just a little bit of code bloat, it is excessive code bloat if you're copying and pasting code or repeating patterns. Because it isn't like a 10 or a 15% increase in your code size. When patterns are being replicated and not simplified, it's 2, 3, 4, 10 times code bloat because you are doing the same thing 10, 12, 4, whole numbers of multiples of times. And that adds a lot of complexity and work to just maintaining it. But more importantly is the bugs and inconsistencies. When you've got a set of things which really essentially should be identical, but they're each their own copy, when you need to make a change to them, you have to go change all of them, all of the copies of that code or all of the repetitions of that pattern. And you need to better change each one of them exactly correctly. Otherwise, you're going to introduce inconsistencies or worse, bugs. Can't tell you how many times I've seen when there are multiple copies of the same solution, we discover a bug in one of the instances. Someone goes in and fixes that instance, but the other n copies still have the bug. And then we come back later and rediscover the bug somewhere else. And I've had clients say, why does it take so long to fix this bug? This bug keeps creeping back up. Well, it's because we've got n copies of that bug in our code. It's a major problem to have code duplication. So I'm hoping at this point you kind of have a sense that drying things up is really important. And I also want to kind of underscore that it's pretty deep concept in computer science. And I don't know if a lot of people give it that level of credit. I didn't learn about dry until 10, 15 years into my career. I didn't learn that acronym. I kind of had learned sort of instinctually what it was, but I finally heard it when I switched over and started programming in Ruby. And as soon as I heard it, don't repeat yourself, just really worked for me. I really like that phrase. And, drying up your code, it has a great verb. But if you really think about it, drying is about eliminating pattern repetition at all levels. Certainly at the most basic level, it's taking a fully duplicate string of code that's been copy and pasted somewhere else and realizing, oh, that's a full duplicate, like you've copy and pasted a function and it's in two different places, it's the same function. You should simplify it down to one and have them both reference the same library. But as I've just shown, it's much deeper than that. It has to do with patterns of repetition and patterns at multiple levels. So you might be starting at function replication, but you might have two different functions with different names, different parameter names. There might be different places, but they are logically exactly the same structure. Then you have the problem with they should be the same, they should act the same, but now if you have to fix bug in one, you're going to forget to fix the bug in the other. And I like to think about dry more about thinking of it as data compression. So I like to think of how, a zip program would zip up some random file, And it looks for not just raw strings of repetition, but repetitions of repetitions and patterns upon patterns of repetitions. And that's what dry is all about. It's finding higher and higher levels, more and more abstract levels of abstraction in your code that you can then dry up. And it has a lot to do with information theory, if you think about it. What we're doing is we're maximizing the information density of our code. Or in the information theory universe, that's called we're maximizing the entropy of our code, which I know if you're thinking about physics, entropy is usually a bad thing. But for information, entropy is a good thing. More entropy means more information density. And really, you're just removing redundancy from your code and making it more concise in your conversation between yourself and other coders and yourself and the compiler and the computer itself. So I ask you, and give you just a second to think about it, what is the result when you dry up repetition? What have you created in your code when you went and dried up a repetition? And it's important. It's a fundamental bedrock of computer science. It's an abstraction. And in fact, I would argue that all abstractions are merely the result of drying up repetition. That is what an abstraction is. An abstraction is taking something that is concrete and repeated multiple times and making an abstract representation that can be used an unbounded number of times. The opposite of repetition is abstraction. And dry ultimately is this path of mastery because there's no level of abstraction at which you can't find a higher, deeper understanding of your code and a better abstraction for it. So dry is one of those practices that once I realized what it was, I have been deepening my understanding of the dry practice at all levels for at least 10 years now. And I continue to find more interesting and creative ways to use dry to write better code. It's extremely powerful. We talked about the levels of code repetition. And again, my emphasis here is that there are an unbounded number of levels. I just wanted to give you a few scales from just copy-paste code to token repetition, to pattern repetition, to architectural repetition. There are many levels and many levels of deepening of understanding. In fact, I think there's really essentially infinite levels. But that's the key thing. Dry is not just about copy-paste code. That is just the very surface of this concept or the tip of the iceberg. We talked about the problems, inconsistencies, bugs, and really huge code bloat. Like once you get it good at dry, you can reduce code size by factors of multiples, 2 or 3x or more. And we talked a little bit about the theory that it really is a form of code compression. You are removing the redundant information in your code and getting it down to the core essential elements of your code. And dry is how you create abstractions. When you dry something up, very often when you're doing something multiple times, the first level of drying it up is to make a function that does that same bit of work. And now you can just use the function multiple times. And then perhaps another level is a module. And there's many levels where you're going to dry things up. And all those other things are subsequently, those are abstractions that come because you were drying things up. And I mentioned about it being a path of mastery, right? There's no end to how skilled you can get at drying things up and making abstractions. It is a limitless well of skill that you can get deeper and deeper and better at. And why do we care about all this? Ultimately, we want to write code faster. And whether we've got existing code that we want to be able to refactor quit more quickly, or if we want to be able to take design code to be very extensible and be able to add new functionality to it very quickly, we need that leverage. And leverage comes from abstractions. Abstractions are perhaps our most powerful form of leverage in computing in general. And all of that comes from this core concept of drying up, taking a set of concrete repetitions, making an abstraction, putting it in one place, testing it once, getting it correct once, only having to fix it in one place, and then being able to use it a million other times. So with that, I will say thank you for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.